Hello and welcome to my webinar about developing games for Windows. My name is Petri, I work as a technical evangelist for Microsoft, and today I'm going to be using Unity 4.6 to implement a simple 2D game. The game is going to be another clone of Flappy Bird. I know there's 1,000 of them out there, but still it's a simple game to implement. The mechanics are simple and I'm going to be able to do it in around 40 minutes. If you guys got any questions or if you feel like you want to reach out to me, feel free to use my Twitter handle at PetriW. So this is going to be our main guy. It's ghost-like shape, it looks rather happy, and he's going to be flying around in an environment where gates of lights are flying through towards him, and he needs to get through them in order to get points. If he hits the ground or if he hits the gates, it's going to be game over straight ahead, so you got one chance to do this. You guys know the mechanics here, so I don't think I need to explain them a lot, but if not, you're going to be able to see this throughout my session. So first of all, to get started, you're going to need Unity 3D. Unity 3D can be downloaded for free at unity3d.com, and it comes in two versions. The free version will get you far, the pro version will get you even further, but the free version is enough for what we're going to be doing today, and you can just hit download here to get started. Anyways, once Unity is installed on the computer, you can go ahead and fire up the game. I'm just gonna do like this, and here we go. And we're going to be creating a new project. So this is the Unity project wizard, and it needs a name for the project. And then you also can import some packages or libraries that the game will be using. You can do this later while you develop the game, so I'm going to go ahead and select nothing in here. And I want to change the settings to 2D. The differences between 2D and 3D when it comes to Unity is basically nothing. If you can make a 2D game in Unity, you can also make a 3D game, because it's the same principles, the same workflow. The only difference is that you'll be using some different components here and there, but other than that, it's a rather simple approach to create a 3D port of any 2D game and so on. So first of all, I'm gonna name this game webinar and Steve the Ghost. It's gonna be the name of the game, so I'm just gonna use that as project name. But if you don't know the name of the game, you can just go ahead and choose whatever you want in here. Hit create. Unity will then be loading and creating my new project, and then we're going to fire up the environment with this project loaded. Right now it doesn't contain a lot. The only thing in fact is that it contains a camera object. Let's have a quick tour of the Unity interface before moving on. First of all, up here you got the manipulator tools. You can move around and pan around in the scene with this one, and then you can move, rotate, scale the selected game object. Then you have the main view here, which is actually a render of the scene. You can build everything you need in here, and you can see the results in the game here. You can hit play to start playing the game. Right now the game is working. It runs on around 80-70 frames per second, and it renders a blue screen. So it's not very interesting, but that's our job to change. Let's head back to my scene. Here we can see that in the scene we have a camera object. I can click it and stuff happens on the interface. I can also click it here in the scene hierarchy. This one contains everything that this scene has loaded at start. So basically what we have here is a main camera object. The main camera object contains of a different components. So Unity is a component based engine. What you do is to add game objects, which is basically an atom in the gaming world of Unity. So a game object is added to the scene, so everything in Unity is based on game objects. So the main camera here, it's a game object. The name is main camera. You can see that it got a transform component attached to it, as well as a camera and then some other stuff as well. So this transform object is mandatory. You cannot remove it from the game object. It contains the position, rotation and scale, which is basically these tools we have here in the middle. It also contains a component called camera, which actually tells the game object that, hey, you're now a camera. Camera is actually just a script or a class that follows Unity that you can add to any game object, and it will be turned into a camera. Here we can see that the background of this camera is going to be a color, and you can change it. You can see the result down in the preview of the camera or in the actual game view. Right now I'm going to just put this one back to something like this. On the last part from after inspector is the projects folder. The project folder is actually everything that the project has in it. It could be scripts, it could be 3D files, it could be 2D files, everything you need to build up your game. So to get started with our game, we're going to be needing some graphics. This graphics is creating using like paint.net. You can just right click here and you can hit create and a new folder, and I'm going to call it GFX. We see now in this project tree that we have a new folder called GFX under the assets folder. The asset folder is like the root of this game. Everything that you add to this tree is going to be an asset of the game. So we're going to add these graphics files to my project here. Just drag and drop from the folder you create, and it's going to be copied into the game. So this is not a reference to where you drag them from. It's actually being copied into this GFX folder. So the next thing we're going to be doing is to add our main character to the scene. What I could be doing is to just go ahead and create an empty game object, and then I could go and attach like a sprite renderer component to this, and then select the sprite I want to be using to this object, and we're going to have it in the scene. Another way is to just go ahead and drag my graphics to either the hierarchy or the scene. I will be dropping into the hierarchy. You can see that we now have a ghost. It got a transform attached to it and a sprite renderer, which is automatically referenced to the sprite here. So if you go ahead and go to the game now, we can see that this is how the game looks like. It's not very interesting. If I hit play, nothing is happening. So let's add some more dynamic to the game. First of all, I want to make the ghost a little bit smaller, like 0.5, maybe even smaller than that, like 0.25. So I'm just scaling it down quite a lot. Here we have a character, and I'm gonna go ahead and change the background of a scene to like more darkish, just to see it a bit better. And then I need to make this ghost a part of the physics engine for in Unity. So Flappy Bird, it always got a gravity that drags the bird down. We're going to be adding the same thing to our ghost. So to do this, we're going to add a new component to the ghost. We're going to physics 2D because it's a 2D game. If you'll be making a 3D game, it will be just the physics part here. So just remember that difference. We're going to be adding a rigid body. So rigid body components attached to any game object tells Unity that, hey, this game object is part of the Unity physics engine. Include this in all of your calculation. So it's that simple. So if I now go ahead and hit play, our ghost will start falling down because gravity is pulling it down. Also, in Flappy Bird, I will need to increase the gravity a little bit. Right now it's 9.81, which is basically the same as we have here on Earth, but I want it to be even stronger than that. So I can go ahead and go into the project settings. I'm going to choose physics 2D, not the physics here because that's for 3D games. Physics 2D, and I'm going to increase this one to say like 25. So here we have our ghost, it got a physics component to it, but it also needs to have a collider, because right now it's just a sprite that will basically go through anything because it doesn't have a collider attached to it. So collider, you can still go into the physics and you can say that it's gonna have a box collider. You can also have a polygon collider, which will make a perfect collider for our sprite. I'm gonna go ahead and choose this. If we go to the scene, you can zoom in a little bit on the ghost here, and you can see that it actually tried to generate a polygon that's perfect around the ghost. In this particular game, we want the collision box for our player to be perfect, because if you add a box collider to it, like I'm gonna go ahead and create this just to show you the effect, like box collider. Oh, I cannot add that, so I'm just gonna see if I can do this. Here we see that a box appeared around it, and you see there's a lot of space around here that will be triggered if hit by one of the golden gates. I don't want that to happen because it needs to be perfect in a game like this. I could, however, decrease this one a little bit, so just the core of the ghost is inside. That would work because it gives the player at least the chance to hit it without being in the invisible space. Alright, I'm going to remove this component and I'm going to re-add the polygon collider to it. So the next thing we need is to add some logic. The mechanics are simple. If you tap the screen, or if you click the mouse button, or if you hit space, or anything you want, the gaze is going to change direction to upwards. Basically, it adds force to the game object in upwards direction. So if I go into the assets folder, I want to create a new folder here called scripts. And in here, I'm going to be adding a new C# script called ghost handler. It could be anything you want. And actually you can see that adding a ghost handler script to the game actually creates a class, public class ghost handler, which derives from the mono behavior. It contains two functions. One is start and the other one is update. Start happens at the start of the game or when the game object is added or instantiated to the scene. And then the update loop is going every single frame. So what I'm going to do is to drag this component over to Ghost. So you can see that Ghost have now a new component, which is our custom component, which is based on the Ghost handler script. So I can just double click this one and it's going to launch up in Visual Studio, and I can start modifying the code and the logic that the Ghost is going to have. Here we are. You can see the familiar functions are in there, and what we're going to be doing is to go into the update loop and we're going to check if the mouse button has been hit. If it's been hit, we're going to add some force to it. So this is rather simple. I'm just going if input dot get mouse button, and I want to be doing it in down. I'm going to look for the left mouse button or a touch on this on a touch interface. So this function will check if the mouse button, the left one, because it's 0 here, is being clicked down, or if we've been touching the touch interface of any mobile device or a tablet. So if it's down, I'm going to go to the rigid body to the reference of our game object. So this one is actually a reference to the rigid body component attached to this game object where this script is running. So basically our ghost. We're going to add force, and we want the force to be going upwards, and let's say 10.0 is a good number. We just need to test that, but we'll see. and we want the force mode to be impulsive. So what happens is here that we tells the rigid body of this game object that you're gonna get a force. It's gonna be upwards in a unit of 10. So vector2.up is basically the same as vector2 up equals new vector2 and 0.1, which is pointing upwards. And then we multiply this with 10, so it goes 10 units upwards with a force. So we also want to reset the velocity of this game object, because I don't want this will be relative to the speed is going up or down. So if you hit space or click the screen 2 times in a row, it will get like 20 here instead of 10. So we just need to reset this so it will apply the same amount of force whenever you hit something on the screen. So I'm gonna go ahead again to go to this one, and then I'm gonna go to velocity, and I'm gonna set this one to 0. Alright, let's go ahead and check the game right now. Play. Hitting the play will automatically get it into the game mode. You can see that the object is now moving up and down, and if I touch the screen or click the left mouse button, it will be moving up and down. It's rather static, so I need to add some rotation to my ghost. Luckily that's simple, because we already have a reference to the rotation of our game object. So I can go ahead and go to rotation, and let's try it if this one looks good. I could check the speed on the up and down direction. I'm going to use that as a basis for my rotation. Let's see how this one looks. Just try it out. Alright, play. Here you can see our ghost is now moving up and down, and it's getting rotation based on how fast it's going in the y direction. Alright, so that's the ghost object. The next thing I want to add to the scene is the background. If I hit the ghost object, you can see that the sprite renderer has a layer ordering on it. Layer 0 is one of the layers. I can change this to layer 1. And layer 1, now this layer tells the sprite that you are going to be rendering in front of anything that's below layer 1. So I'm going to go ahead and drag the background to our scene like this. You can see that this is ordering layer 0. If I change this to 2, it will be in front of the ghost. 1, it will be the same with the ghost. It's going to be some maybe even some flickering, so avoid having the same layer on things that you want to have in the different layers. So I'm going to go ahead and keep this as 0. And if I go to the game scene here, I want to make the background repeat itself over and over. So first of all, I can go ahead and create an empty game object just to have some structure here. Background. I'm just gonna reset this to 0, 0. I'm gonna drag the background into this one just to have some order in the scene, because I want to have a lot of these background objects here. You could create a one big picture, you could use a tile renderer or anything you want, but I'm just gonna do it the simple way. It's by dragging this one here. By the way, if you go ahead and click on game object in the scene and hit Ctrl D, it's going to create a duplicate of that game object. So just make sure that it fits perfectly. I'm going to do the same one in the back here, like that. And another one. Let's see. There we have it. A nice background for our game. And because I added this inside of a game object, I can just close this one and it will be hidden, not cluttering my hierarchy. But it could be outside, anything you want. Just make sure you got the chaos you want to have in the scene. You're going to be working with this a lot, so do what fits you well. As you can see, this is a game object. It's just a transform here, and everything that's inside it will have this transform object here as the relative reference. So these are positioned relatively to this one. So if I move this background now, you can see that we're moving everything at once because these are positions relative compared to this one. Alright, there we have the background. I also want to add the ground to the scene. The ground is going to be far down here, like that, and I'm going to call it ground, that's okay. And I want the ground to be moving. So there's two approaches here. I could create a scene that's really long, and I can move the camera to, at the same pace as the ghost object. Or I can simply move everything towards the game object, that's the ghost, and the gates, and have the camera standing still. So basically what I'm going to do is to move the ground here in the X direction. To do this, I'm going to add a new script. Create C# script, and I'm going to call it like ground handler, and I'm going to attach this one to our ground object, like that. I'm going to open the ground handler, and I'm going to create logic that moves this one in the correct direction. So this is simple. I'm just going to go into the transform object. This is reference to the transform component of this game object, and I'm going to move the position of this because we also have a rotation here, and also the velocity scale and the local scale. But we are in here for the position, and we're gonna move it. Oops. It's a new keyboard, so I just need to get used to it. And we're gonna be moving this in the right direction. And let's see if we have a speed here. 7 might be well. And also we need to sync this up with time. So delta time, it's just a float number, and it includes or contains the amount of time that has passed since the last frame was rendered. So if you're on a slow computer, this one is going to be big because it takes more time to render a frame. If you're on a really quick computer, this one is going to be small because it takes a short amount of time to render a frame. And this will be synced up to the clock, so this speed will be the same even if you're on a low-end device and a high-end device and a supercomputer. So basically what we say is that we're going to move the ground 7 units per second. And also I want this ground to be looping all over. So I'm gonna check if the transform position and the x-axis, because that's where we're moving, is less or equal to 20, for example. I know that's gonna be far out of the scene, because if we go into Unity and I hit the ground object and I move it backwards, you can see that it disappears off the screen in around 13. So at 20 here, we want it to be spawned in front of us and then move like this. So it's just going to be an infinite loop where it just respawns itself whenever I need it. Then I'm going to set the position of this one to the right. Oops. And I want it to be 20 units in front of me, and of course I forgot to have a minus here because I need it to be behind me, and I'm going to put it in front of me. Also, this one will set the position in the middle of the screen, but I want to keep it going on the down side of the screen. So I'm just gonna add the down position as well, and let's see where we have it right now. Minus 4.37. I'm just gonna copy this number into this one. So I have down here, which is -1, and I multiply that with 4 to get the correct position. So if I go ahead now and save this, and I go into the game here and I hit play, you can see that my game object is moving backwards, and then it spawns in front of me, and then it does that all the time. So I'm going to go ahead and create a new folder on my scene here called prefabs. Unity is using prefabs as a way of creating a game object that I want, and you can use it wherever you want in the game. So basically, to do this, I have my ground object. I can just drag it into my folder and it will create a new ground object. Then I can drag it back in here. You can see that I'm adding more of these ground objects here, like this. And I can drag even one more and pull it behind me. There. And I'm going to do adding one more, just to make sure I get all of the spaces here. Like that. And if I now hit play, you see that I've been adding a lot of game objects, and they are all operating in the same way, just because I created a prefab of what of the ground object. So I'm usually explaining this in this way. To create a prefab, it's actually a blueprint of a game object you want to use many times in a game. So you saw that I created the game object, I added the logic I wanted to have on it, and then I created a prefab out of it. The prefab is now an object that I can use anywhere I want in this game, even instantiated by code. So I could actually write logic here that adds these ground objects to the game using code. And that's what I'm really using when I'm creating the golden gates that moves towards us. Alright, here we are. Might even hide my ground objects a little bit. Ground. I'm just gonna reset this like that. I'm just gonna drag this in here. I can even call this ground handler. It just includes everything here. Whatever, it ain't very important. It still works, you can see, because everything is relative to a ground object. Alright, the next thing we want to do is to add collider with the ground, because we want this ground to be dangerous. If you hit the ground, you're gonna die. So I'm gonna go ahead and add this one to the physics engine of our game, because everything that you want to be collidable with another physics objects needs to have a physics object itself. And I can go ahead and hit is kinematic, because I don't want it to be affected by anything that collides with it. I don't want, if you hit the ground with a ghost, I don't want the ground to be falling down. I don't want to have gravity that affects the ground or anything. So I'm just going to put this is kinematic. It's going to make the object stable. It can even fly in the ground. It's just going to be collidable. And if I hit apply here, you can see that all of my other game objects that's based on this prefab, it's getting the same changes. You can go ahead and create a box collider here. And if we go into the scene, we can see that it automatically found the size of a sprite and created a box here. And in this case, it's okay to have a box collider, because I'm actually having a rectangle. And the box collider can work as a rectangle, and you can set the sizes here, and you can also set the center of the collider to wherever you want. So, but this is good, and I'm going to hit apply again, just to have it there. You can see everything got this one, got the changes I made. Now you can see that if I hit the ground, it's actually going to be colliding with it. That's okay. So, before we write the logic that makes things dangerous, I want to have the gate objects. To do this, I still want to use the let's see here. I still want to be using the same kind of mechanism that moves everything towards the player. So first of all, I'm going to go into the scene. I'm going to be dragging the hinder object in here. I can move it a little bit. As you can see, we're going to need to scale it. And I just do this, and I want it to be like this. It should be quite high, because the way this is going to be working is that I want to create a gate, and the gate will be positioned at random heights. So I need to make sure that that's covered. I'm also going to go ahead and create a new game object, and I'm going to call it hinder. And I want to position this at 0, 0 just to be working with it. And I'm going to call this one for 1. I'm going to drag it in there and move it down here. And then I'm going to create another one, 2. And I want this one to be up here. Now you can see that we have created a gate. I want this to actually be the same. So I'm going to go ahead and change this to say like 7. And this is going to be -7, like that. You can also highlight these two and add a component to it. Need this to be part of the physics engine as well, because it's going to be collidable. It's kinematic for the same reasons as the ground. And let's see here, I'm also going to add a box collider to it, like this. You can see that the box collider is the green rectangle we have around it. A bit hard to see, but that's okay. So, we want this hinder to be doing the exact same thing as our ground object. So I can go ahead and go into my ground handler, and I can move it at the same speed here. So I'm just going to copy this one line, and I'm going to creating a new script here. Create C#. And let's call this hinder handler. I'm going to be dragging this one onto the hinder, because if I move this one, you can see that both of my gates are actually moved. Also want to make sure that this is positioned at the 0 position of the hinder, just to avoid having any offsets. So if this is 7, I want this hinder to be 7 as well. So let's see if we can get this thing moving. Here we are. And I also want to check the position of this, but I don't want this to be repeating. I could do it so it repeats all over and over and over again, but what I want to do is that if this position of this object is less, or let's go to the X one, is less or equals to -20, I actually want to remove it. I want to destroy it. So I have this function called destroy, and I just need to pass in the game object of the object this script is attached to, which is the hinder game object, and I want to destroy it. This one actually just goes ahead, takes the game object, and removes it from the scene. So I'm going to go ahead and save, and I'm also going to move this over to a prefab, like this. Here we have it, and I can delete it from the scene. So now I need to create a game handler that spawns new gates, say every 1.5 seconds. I want to spawn a new gate, and I want it to move backwards, and now I want it to be removed, and I want to position it on a different height for every time it spawns it. So I'm going to go ahead and create a new game object. It's going to be empty. You can set it to 0, 0, and I'm going to call it game handler. The game handler is going to have a new script attached to it, so I'm just going to go ahead and create a new C# script and call it game handler. Alright, I'm going to drag the game handler over here, and I'm going to open up the script. So the game handler will keep track of time, and for say every 1.5 seconds it's gonna spawn a new game gate. So I need to have a spawn timer, and then I also need to have a timer that I can control from the game. So let's go ahead and create a new public. I'm going to show you why I'm choosing this to be a public one soon. I'm going to call it time between, say, hinders. Time between hinder, like 1.5. So what I'm going to be doing here is that I want to reduce this for every frame. I want to say that this one should be reduced by time.delta time. So this is actually seconds. So this one will now mean that 1.5 is 1.5 seconds in real time. So if spawn timer is less or equal to 0, I want it to set the spawn timer to the value we'll be choosing in here, and I want to instantiate. So instantiate is a method that comes with Unity that creates a new instance of a prefab. So if you think of a prefab as a blueprint, instantiate is the fabric that creates, or factory that creates a copy of this blueprint to wherever you want in the scene. So what do I want to instantiate? I need to instantiate the hinder game object. So I'm creating a new public variable of the type game object, because every item in Unity is a game object, and I want to call it like a hinder prefab, like this. So I want to spawn a hinder prefab at the right position 20 units ahead of us, which is outside of the screen, and I want it to have an identity matrix quaternion as the rotation object, so basically it doesn't have any rotation. So what I'm saying here is that I want to instantiate this prefab 20 units in front of me or to the right with 0 rotation. So I'm going to go ahead and save this, and we need to populate these two values. We need to set this one to something, and we could override this one to be something else than 1.5 real time when we're playing the game. So if we go ahead now to the game handler, we can see that the public variables in our class are actually showed in the editor. So this is 1.5, which is fine, and I also need to pass in the hinder game object as a parameter to the hinder prefab. Now we're actually setting the hinder prefab variable to be equal to this game object. So if I go ahead now and save this, and I want to save the scene as well, so I'm just gonna hit Ctrl S to save, and float, and scene, and I'm gonna call this game. Save, because this is actually the actual gameplay of the game I'm creating. So if you go ahead now, you can see that we're getting hinders, it's being spawned, you can hit them, nothing happens, but it's still playable. This could actually be a cool game if you do the right thing. Alright, we're gonna stop it, and wait, I'm just gonna show you how to affect the time. So I can just go ahead and hit pause, go into the game, I can go to the game handler, and I can say this to be, say, 0.4 instead. see that the changes are affected immediately in the game. But if since I've been doing this while playing the game, since play mode was active, when I stop it, it's going to go back to the default. But if I would be changing it now and hit play, that setting will be saved. So play mode is a good way to test values, play with them, and when you stop it, it's going to go back to normal. Alright, so we need to start dying, and we need to keep track of the score, and we need to find a way for the game handler or the game logic to understand that we actually passed a hinder. So what I'm going to be doing now is I'm going to go in to the scene, and I'm going to add the hinder to this one, and I'm going to add a new trigger collider to this game object. So I'm going to go ahead, physics, it's still going to be a box 2D. I'm going to say that this is going to be a trigger. The center is okay. I want this to be a bit narrow and it should go up. Or actually I want to move it to the end here. So what I want to do is to have some logic that checks if the ghost has gone out of this trigger zone. So if the back of the ghost is going out of this trigger, we will get 1 point. So it's going to be quite simple. Since we only have one trigger in the scene, we can go ahead and check that if we go out of any trigger, something will happen. So I'm going to go and apply this. So the game object is being saved, and I can delete it from the scene, and I can go into the code of my ghost object. Let's see here, ghosts. So Unity comes with another function called on trigger exit to D, and it takes a collider 2D as a parameter, and I'm going to call it the other. Oops. So this function will trigger every time this ghost object is going out of a trigger zone. You also got one on enter, which means that this function will start when you're going into a trigger zone. And you also got another one that checks if you are inside of a trigger zone. It's called onTrigger stay 2D. Alright, in this one, I know that we're exiting one of the triggers, so I'm going to create a new variable called score, and I want to add score with 1. And also, I want to debug the information, because right now we don't have an interface that displays the score. So I'm just going to go ahead and log, and I'll say score. Like that. Alright, and if you go ahead now and play the game, you can see that I have 1 point here, 2 points. You can see it down here. I can also bring up the console here, like that. Continue playing the game. You can see that I'm getting a point for every time I'm going into the gate. What else? I want to check if I'm colliding with the environment. If I'm colliding with the environment, I want the player to die. We got another function that is called on collision enter. There's also going to be a 2D, since this is a 2D game. Collision 2D other. This is the other one here is a reference to what I'm colliding with or what kind of trigger I'm going out of. So if you want to check that if trigger is this or that, you can just reference to the other object here. So if this is happening, I want to actually just restart the game. Alright, and for this function to work, I'm gonna have to tell the game what game actually is. Because right now I have a scene called game, but it's not actually a part of the game yet. So if I go into the build settings, I can go ahead and drag this into the scenes in build, or just add current, because I'm currently working with this one. You can see that the index of level game is now 0. 0 is the index of the game level that will be started when you launch the game in an exported version of the game. Alright, so let's try it here. If I hit the ground, I'm dying. And if I hit one of these, I'm gonna be dying. Alright, so that seems to be working. Alright, let's render our score. I was kind of wondering why I'm getting these black artifacts here. Okay, it was a one-time thing, so that's okay. To do this, Unity 4.6 comes with a new UI toolset to make user interface development a lot simpler than it used to be. So back in the days, we actually used third-party tools that other developers had made available for Unity to create user interfaces. But in this version of Unity, it actually comes with a really good tool set of Unity user interface development. So to do this, I can go ahead and I can find the UI menu item here. I can select what I want to add. I want to have a text object. So what happens now is that it was added a canvas object, a game object, to the scene. This one contains a rect transform instead of the normal transform, which is basically another way to give a position of an object, which makes a lot of sense when you work with user interfaces. He also added a text object, which is what I wanted. You can barely see it here. And an event system that is used to handle events from buttons, or if I click text, or if I interact with the user interface. This one is handling everything of that. So I want to go ahead and change the color of this text to white, and I would also like to change the size of this one. I'm just gonna turn off the 3D gizmo effects because the camera is too big in the scene. Alright, these gizmos are rendering of these icons. You can see the camera component has a gizmo attached to it, which renders the camera on the position where the camera is. I can choose to turn off the grid. I can change the sizes of the gizmos like this, so it's easy to see in the scene. But I'm just gonna turn off the 3D gizmos off. You're still gonna be able to see it, and you can turn it even off here if you don't want to see the camera. So let's move the text up. I want to have it in the top position of the scene. Let's go here and work it there, and let's drag this one up here, and I want to change the size to 72, for example, and I should overflow this. I want the scene to be in the middle. So this one just said that it shouldn't care about the rectangle size of the width and height rectangle of this game object. You should just, if it's big, it's going to go outside of the rectangle. So my rectangle is actually going somewhere here, but the text is a lot bigger than that. And I'm just going to put this at 0 because that's the points I have right now. Alright, here we have a new text object, and I need to reference this from our ghost handler and update it every time I get a new score. So to do this, I need to put a reference to it, and I need to be adding a new using statement here. It's using, and then it's called Unity engine.ui. Then we'll have access to something called text, which is basically a text game object for a user interface. I'll call it score text, for example. And every time I'm getting a new point, I want to set the value of this to score score dot toString, because it needs to be a string. There we have it. And if we go ahead now and start playing the game, it will crash because I don't have anything referenced to this, because I forgot to put it. So if I go into the closed object, I can drag the text element into the score text here. And now it's set. There you have it. Oops. I'm getting some artifacts here. It's probably because of my camera software is interfering a little bit, but you get the picture. Alright, so what you could be doing here is that if you die, you want to display a new UI game object here with a replay button, with a medal, with anything you want to tell the player after a round. Right now it's just respawning the player in the game and actually never giving the player a break, so it could be a good thing. Alright, I want to add another thing, so I'm going to change this name of this to score text, because I want to add another thing here called high score, like that. And I want this to be positioned in the bottom of the screen. You can also use anchoring, which is an advanced feature, and I'll be adding a link to a tutorial that tells you how to always say that this text should be positioned, say, 5 pixels from the bottom of the scene instead of from the center. You can use these anchors here to choose this. There's a quick anchoring overview here, so you can anchor things down to the bottom, this side of the screen to up here, and it will. Okay, I can go ahead and do this. I can process at 0 here, and I want this to be added like this. And now I see that it's anchored 37.7 pixels or units from the bottom of this screen. So if I resize this one, you can see that the top of the game score is moving out of the screen, while the bottom one is staying inside. So you can go ahead and change this one to top anchor instead. Now you can see that if you change the screen resolution, the scoring will always stay here. So I can call this best. Oops, that's the wrong one. Best score. Alright, and actually I want to anchor this down here and move it over there, and I want to have it a little bit smaller, like 32, so you can still see it, but it's not in the focus of the game when you're playing, so it's not interfering with the player. So I'm gonna go back into the ghost object here, and I'm gonna create a new integer called score best, for example, and every time I'm getting a new score, I'm gonna update the best score based on what I have here. So if the score is bigger than what I had in the best score, I also want to update the best score. I also want to make sure that if I'm dying, like here, let's see, if I die, I want to save the best score to the system. Unity comes with something called player prefs, which is a way to store settings and small data points like an integer, variables, or anything you want to the memory or to the hard drive, so you can load it whenever you start the game. So this one will actually be saved. If you close the game and you go to sleep and then you play the game that after, you can use player prefs to store the stats. So I want to set an integer into player prefs. I'm going to call it best score, and I'm going to use the best score here. Now I'm saving the value I have in best score into this position in the game as an integer into player pref system. So what I want to do is to load this one when I'm starting the game. So I'm going to say that best score equals, and I'm gonna choose this into getInt, and if it doesn't exist, it's using 0 as a default value, which means that you haven't played the game before. So start the best one is 0. Save. Another thing that I want to do is to get a reference to the best score in the game. So let's see, best score, and I want to update this all the time, and let's call it best instead, plus best sum. Don't need to do this, but I tend to just do it. Alright, and we need to set a reference to the best score from the game. So I'm just going to go into our ghosts, and you can see the best score text here waiting to get something in there. I'm going to do the high score into this one, and then I want to change this one to best score. It will get changed in the update, but you know, just to have the right interface when I'm not playing the game. So I'm going to go ahead now, I can play the game. I died. Let's see here. That's 1, that's 2, that's 3. And if I die, it's gonna stay at 3. It's a hard game. I'm not very good in Flappy Birds, but there I have 1, 2, 3. There we see the best score is updated. And if I quit the game and I start playing it again, as you can see that the best score is loaded. So there we have it. The game is actually working the way I intended, with one exception. I want the hinder object to spawn at different heights for every time it's getting appearing in the scene. So let's go here, hinder handler. I want this at the start function will be called once the hinder is being instantiated to the scene. So if I go into the hinder handler here, I want this position to be set in the start event. I can go ahead and go to the transform, position, and I want to change the height. So I'm going to go ahead and go to the up vector here, and I want this to be between -2 and 2 in height. So I'm going to use the random function here, dot range, and I'm going to have to like that. So basically what I'm doing here is to get a random number between -1 and +1, and then I'm using this one to get a correct size in the right direction. You could put in 2 in here and -2 and 2 in here to avoid this one, but I like to use this in this way, so as a percentage of this. Okay, if I start playing this game now, you see that I get different heights of the gates. And since I placed the long game object on this one, alright, let's go ahead and I see the reason why I'm having some difficulties with the layering here is that I have different layers. I just forgot about that one, so I need to go into the ground here, and I need to set this one to layer 1, and I want to go in and say that the hinders should be in layer 2, because I want it to be in front of everything. And then we can go ahead and play. And if I die now, yeah, it works. So that was my issue. Sorry about that, but now it's working. So I want to add one more thing to this game, and that's the main menu. It's going to be a really simple one. So I'm going to go ahead and add a new scene, and I'm gonna set the background to like a dark blue like this, and I want to have a graphics on here, a logo called Steven the Ghost. It wasn't Steve, but still. And I have a tap to start thing here, and I need to add some logic to this scene to actually start the game. So I want to create a new scene. Wait, here. And we're gonna add a new scene to the game. And oops, that's what I'm just did here, and I'm going to save it as, say, start or menu or whatever you want. And what I was starting to do is that I needed a new script. Create C#, and I'm going to call it menu handler. I'm not sure why I'm adding handlers to anything. I'm just doing it right now, but alright. I'm just gonna put it out in a main camera. You can put it wherever you want. You can even add your own game object that's called main handler or manager or whatever, but this is good enough. And in the menu handler, I want to check for one thing, and that if the player is tapping on the screen or clicking the mouse button. So it's the same as before. Get button down. So the difference between get button down, get button, and get button up is that get button down is fired only when you, for the first time, press the button. And then you have get button, which is firing all the time while the button is being held down. Or up is when you release it. So if you tap the screen, I want to load the game. Like that. Alright, and that's what we needed. Oh, get mouse down. Like that. Alright, getting tired. Anyway, here we are. And I need to add this one to my game. So I'm just gonna save everything. Then I'm gonna go to build settings. And then I'm gonna add current. I need to change the position of this one because I want the start screen to be where the player starts at. So I'm just gonna go ahead and drag it to start. And then have the game down here. I'm gonna save. And hit play. And if I tap it, I'm starting the game. You can see that the best high score is still 5. It's not as hard as the real Flappy Bird, but you can do some tweaking, you can add stuff to it, whatever you want. So the last thing I want to do is to add a simple particle engine to this game to get some snow into the scene. So I'm going ahead and stop this game. And I want to add a particle system. You can see that I have a particle system added to the hierarchy, which is basically a game object with a particle system component attached to it. So first of all, I want to have the particle system in the center of the screen like this. And I need to get the particles to move a bit closer to me. And I want to go down. And I want the mission shape to be a box, and I need it to be quite wide because I want to spread the particles quite a lot. It could actually be even wider than that. Whoops, that's too much. Like this, and I want to move it up here so it comes from the sky. Now I want to change the emission rate of this particle engine from 10 to around 100. And I need the particles to live the life all the way from the top of the screen to the bottom, so say 10 seconds. And also need to make the illusion of movement, so I can go in here and change the velocity over lifetime. And I know the ground is moving around 7, so I'm going to just put this to -5. And I'm also going to change the size of the particles, 0.1, just to create the illusion of snow. If I go ahead here and hit play, you can see that it's starting to snow when I'm starting the game. But I want it to be already snowing when I'm playing the game. So I can go in here and hit the pre-warm flag and hit play. You can see that the snow is already in place in the scene when I'm starting. So the last thing I want to do is to save the game and hit build settings to create a Windows Store export. I want to upload this game to the Windows Store. So I can go in here and select the 8.1 from the drop-down menu here. You can also change it to phone or universal. But I'm gonna stick with 8.1, hit build, and go ahead with the 8.1 folder. And now Unity will export a Visual Studio solution, which is similar to what you would have get if you were creating a normal Visual Studio application for Windows Store. So if you go into Visual Studio on File, New Project, and select Windows 8 application and hit Generate, it will create a similar project structure. But this one comes with our game built in. So here we have it, our game project. Got the normal hierarchy here, and you can select what kind of layout you want. You can go ahead here and hit deploy on local machine. It will then build the solution, the packages, and then it will deploy these on your own computer. If you want to change the tiles of the game, you can go in here and change everything you need from this one, like this splash screen and so on. And here we have it, our game up and running on Windows Store machine or Windows 8. Play the game, we can see the snow in the background, some mountains, the ground is moving. You can die, but I'm restarting all the time so you can never get a break from playing this game. Alright, that's it. Lastly, I want to just show you the last slide I'm having here, and that's the Develop Challenge. So at develop.com you can go in there and create your account and get started with completing challenges. It's a gamification system, so you can get experiences and points for completing challenges, which you can then use to buy actual hardware, like phones, tablets, whatever. So go and check it out, upload your games, complete some challenges, and get your hardware sent to you through the mail. Alright, thank you very much, and thanks for following.